Hello everyone, my name is Satvik and I'm going to be explaining the turn block in the LEGO Spike Prime app. Before we dive into what a turning block exactly is, let's understand the different types of turns. Also, I will be using the terms inner wheel and outer wheel a lot during this presentation. When the robot is turning, the wheel inside the turning circle is the inner wheel and the wheel outside the turning circle is the outer wheel. So, if the robot is making a right turn, the right wheel becomes the inner wheel and the left wheel becomes the outer wheel. Similarly, if the robot is making a left turn, the left wheel becomes the inner wheel and the right wheel becomes the outer wheel. There are three types of turns. The first one is a pivot turn, second is tank turn or swivel turn, and the third one is a smooth turn. The pivot turn is when the inner wheel does not rotate at all, while the outer wheel rotates in the direction of motion. Since the inner wheel is not rotating at all, the center of rotation is the inner wheel itself. And this here is the radius between the two touch points. This is what a pivot turn looks like. This is the inner wheel, this is the outer wheel. That's what a pivot turn looks like. The tank turn is when the inner wheel rotates at the same speed as the outer wheel, but in the opposite direction. This means that the center of rotation is at the midpoint of both wheels and causes the robot to spin. And the radius line here is between the middle of the robot, or this blue beam, and the outer wheel. And this is what a tank turn looks like. This is going to be the inner wheel, this is going to be the outer wheel. Outer wheel is moving in the direction of motion, and which is this way. Inner wheel is going to move the opposite. Like that. The smooth turn is when the inner wheel rotates in the same direction as the outer wheel, but slower. This causes the robot to turn and the center of rotation to be outside the robot. The radius here is between the blue beam and the center of rotation. This is a smooth turn. This is the outer wheel, this is the inner wheel. That is a smooth turn. Now let's come to the point of what is a turning block. A turning block is this pink block with a bunch of settings. When you click on the first white box, you get a drop down with a steering wheel controlling the turning angle. And this first white box controls the inner wheel. You can drag this arrow left and right. When you drag it left, then the robot turns left. When you drag it right, then the robot turns right. Also, keep in mind that the 30 does not mean that the robot will turn exactly 30 degrees. We will explain more on that in the next slide. Let's break this first white box down. So this right turn means the direction of motion, or the robot turn direction. And the 30 represents the speed of the inner wheel compared to the outer wheel. Now, let's see what happens when we click on this pink box that says rotations. Oh, you get another drop-down with 3 other motion types: rotations, degrees, and seconds. When rotations are selected, the user can define how many rotations the outer wheel should make. When degrees are selected, it defines how much angle the outer wheel should turn. And if seconds are selected, the wheel will keep rotating for the given amount of time. And these are all motion types. Now the number next to it represents the motion amount. For example, if 2 rotations are selected, that means the outer wheel is going to rotate 2 full turns. With the degrees option, 720 degrees will make the outer wheel take 2 full turns. If 5 seconds are selected, that means that the outer wheel will keep rotating for 5 seconds. Let's look at the steering angle block in more detail. One way to understand this is by using the 0 to 100 scale. When the angle is set to 0, the inner wheel rotates at the same speed as the outer wheel and in the same direction, causing the robot to go in a straight line. When the angle is set to 100, the inner wheel also rotates at the same speed as the outer wheel, but in the opposite direction. This means the center of rotation is at the midpoint of the two wheels, causing the robot to spin and make a tank turn. When the angle is set to 50, the inner wheel does not rotate at all, and the outer wheel rotates in the direction of motion. Since the inner wheel is not moving, it becomes the center of rotation, simulating a pivot turn. Now, when you set the movements, when you set the angle between 0 and 50, then the inner wheel rotates in the same direction as the outer wheel, but slower, which causes the robot to turn and the center of rotation to be outside of the robot, simulating a smooth turn. The higher the number between 0 and 50, the sharper the turn gets. Now, this might sound quite confusing, so I find the 100 to negative 100 scale more helpful. The 100 represents the inner wheel rotating at the same speed as the outer wheel and in the same direction, while the negative 100 represents the inner wheel rotating at the same speed as the outer wheel but in the opposite direction. The 0 represents the inner wheel not rotating at all, while the outer wheel rotating in its direction of motion. Also, keep in mind that the 0 to 100 scale is only for right turns. So if you want to use the scale for left turns, then just simply add a negative to each number. Also, please note that there are no specific steering angle values that are applicable in all situations. It all depends on wheel size and spacing. Now, let's understand the types of wheels. There's a small wheel, which is included in the base kit. The diameter of the small wheel is 5.6 centimeters or 2.2 inches, and the circumference is 17.5 centimeters or 6.89 inches. There's also a large wheel, which only comes with the expansion pack. The diameter of the large wheel is 8.8 centimeters or 3.46 inches, and the circumference is 27.6 centimeters or 10.87 inches. The diagram here shows the wheel spacing. The wheel spacing depends on your robot design, and you can find out by measuring the distance between the touch points of both wheels. So measuring the distance between here and here. Once you know the wheel circumference, C, and the wheel spacing, S, here is a cheat sheet with the variable values for a 90-degree turn, which only works for the small wheel. There are three variables: turn angle, which we're going to refer to as T, wheel rotation, which is R, and wheel rotation angle, A. The turn angle for the pivot turn is 50 and 100 for the tank turn. The wheel rotation for the pivot turn is 0.786 S by C, and for the tank turn, it is 0.393 S by C. The wheel rotation angle for the pivot turn is 282.78 S by C, and for the tank turn, it is 141.39 S by C. Notice that the values of the pivot turn in R and A are double the values in tank turn. Also, I won't be talking about seconds here because that requires other complicated factors which we are not going to talk about in this video. Now, if you would like to determine the rotation block settings for other angles, I have made an Excel calculation sheet where you can input variables and get the rotation block settings. The motor max RPM input is going to stay constant, and is only needed for rotation time if you're using seconds. Thank you.